Section 1-2 is on linear measure. A line segment is a part of a line that is determined by two endpoints. You'll remember in the last section we talked about lines. That is the set of all points between any two given points that extends infinitely forever. Now a line segment is basically just a piece of a line. So I could refer to this whole diagram as line AB, but if I'm talking about just part of it, and that is the points that are between and including points A and B, that's considered a segment, and it's designated like this. So an uppercase A, an uppercase B, and a line over the top that does not have arrows on it. I could also refer to this as line segment BA, the order doesn't matter, or I can write the word segment out. So line segment AB. Note that a line extends infinitely, but a line segment is actually finite in length and can be measured. I cannot measure line AB because it goes on forever, but I can slap a ruler down and tell you exactly how many inches or centimeters segment AB is. So another note on kind of notation. The name of this segment is CD with a line over the top. Its length is CD without a line over the top. And I know that sounds kind of picky, but a notation and the way you write things is very important in geometry. So CD with a line over the top is the name of the segment. CD without a line over the top is the length of the segment. So I would have to say the length of CD with a line over the top is 5 inches, or I could write CD without a line over the top equals 5 inches. Another concept is called the betweenness of points, and it says that M is between points P and Q if and only if P, Q, and M are collinear, and the length of PM plus the length of MQ equals the length of PQ. Let me say something, kind of step back and talk about this if and only if. This will come up a little bit later, I believe in chapter 2. That means that you can flip this sentence around and it's also true. So if I were to say if M is between P and Q, then all of this stuff is true. I can also say if P, Q, and M are collinear and PM plus MQ equals PQ, then M is between P and Q. So if and only if just means you can kind of switch the first part of the sentence and the last part of the sentence, and either way it's true. So let's take a look at this. I have points P and Q are the endpoints of my segment, and point M is anywhere in between. And it seems kind of obvious, but if I were to measure the length of PM and then measure the length of MQ and add them together, I would get the length of PQ. Let's use that in a couple examples here. So find the length of AC. And again, I'm going to reiterate, notice there is no line over the top, because this literally means find how long line segment AC is. Well, line segment AC is actually made up of the length of segment AB plus the length of segment BC. And so since AC is what I have to find, I'm going to leave that there. Segment AB is 4 5/8 inches long. Segment BC is 2.5 inches long. And when I go ahead and add those, that's going to give me 4 plus 2 is 6, and 5/8 plus basically 4/8 is 9/8. Let's clean that up a little bit. That's going to be equal to 7 1/8 inches. Oops, the length of AC is 7 1/8 inches. Second example here says find the length of LM. Well, you notice that the length of LM plus the length of MN is equal to the length of LN. This little segment plus this little segment add up to the big segment. And I don't know what LM is, so I can leave it LM, or if you're feeling like you miss algebra, let's go ahead and throw an X in there. Okay, plus MN, the length of MN is 2.6, and LN is 4 centimeters. And solving that for X, we get that X is equal to 1.4, or the length of segment LM is 1.4 centimeters. I'm going to go ahead and box my answers here. Okay. Here's another example. It says find the value of x and st if t is between s and u, and st equals 7x, su equals 45, and tu equals 5x minus 3. Very important thing to do in geometry is draw a picture. Let's draw a diagram. And I'm not going to worry about a whole lot of this because the main thing I need to know is that T is a point that is between points S and U. So I'm just going to draw a line segment here. Doesn't matter how long. I know S is on one end and U is on the other end. And I know that point T is somewhere in between there. And for this matter, it doesn't matter where I put it. I kind of avoid putting it right in the center because that's a concept that we'll come up with later called midpoint. But for now, just put T anywhere between S and U. And then let's go ahead and label what we know. I know that the length of ST is 7x. And I know that the length of SU is 45. And I know that the length of TU is 5x minus 3. Okay? Now, looking at this diagram, I know that the length of ST plus the length of TU equals the length of SU. And ST is equal to 7x. TU is 5x minus 3. And SU is 45. So let's solve this for x. So that's going to give me 12x equals 48, or x equals 4. Now here's another interesting thing about geometry. Usually in algebra, at this point we'd be done. Most of the time you're trying to find x, and once you find x, you just box it and you're done. That isn't always the case in geometry. Once you've done some algebra and figured out what x is, go back and reread the problem and figure out what they're asking you for. So this problem says find the value of x. Okay, I did that. And the value of st, if all the rest of that is true. So my answer is not just what x equals, I also need to figure out what st equals. So plugging 4 into st, I could look at it up here, 4 times x, or 4 times 7, is going to give me 28. And in this case, I didn't have units on this, so I'm just going to leave it like that. So in geometry, once you've found x, go back and reread the problem and see if you need to find something else. And the last concept here is called the definition of congruent segments. And it says two segments are congruent if and only if they have the same measure. And that might seem a little obvious, but it's really a matter of notation again. So here's a kind of an explanation of it. So given segments AB and segments CD, if the length of AB is equal to the length of CD, then segment AB is congruent to segment CD. And notice, this is an equal sign, and this here is a congruent sign. It's an equal sign with a squiggly over the top. So the lengths of the segments are equal, but the two segments themselves, remember this refers to the name of the segment, the two segments themselves are congruent. And then the converse of that says if segment AB is congruent to segment CD, then the length of AB is equal to the length of CD. Remember, we can only say that the lengths of two segments are equal to each other. So if this segment was 5 inches and this segment was 5 inches, I can say yes, 5 inches equals 5 inches. But I can't really say that this segment itself is equal to this segment over here. Segment AB is not equal to segment CD. We say that they are congruent. And you'll also notice that we have these little slashes on the two segments here, and that indicates that those two are congruent to each other. That is, that they have the same length. So in this section we looked at line segments, and we looked at the betweenness of points, and got a little deeper into some kind of notation that it's really important for you to memorize how to use.